Hey, folks. How's it going out there? We've still got a couple of people filling into the room right now, but I think we're going to go ahead and get started. So welcome to our talk. We're here today to talk to you about how you can use Visual Studio to improve the .NET scalability and performance of your applications. So I'm Steve Carroll. I'm the development lead of the Visual Studio Profiler.
And my name is Ed Glass. I run the team test team in North Carolina, and there we build the web test and load test products, as well as we're building a new test case management server for Dev 10. And how many of you got to Universal Studios last night? Was that fun? Yeah, that was fun. Hey, if you ever want to see something really funny, sneak up behind Steve with a chainsaw. Very jumpy guy right here.
Yeah, because I'm not nervous already. Good. No, it actually does my heart good to see like 1,200 people in a room all wanting to hear about performance. That's awesome. But because there are 1,200 people in the room, and here's my frame advance, I want to make sure that I am really explicit up front about what we're going to cover today and what we're not going to cover. So the talk is broken up into two parts. We're going to talk about the performance lifecycle, and we're going to talk about diagnosing common .NET performance problems. So we really believe that there are like three main ingredients that go into getting repeatable performance, repeatably great performance in your application. So the first element of that is really knowing your platform, knowing where the quirks are, where the gotchas are, the mistakes not to make. But the second and sort of less commonly emphasized one is actually having a really great process around getting performance in your software development lifecycle. And that's something that we're going to focus on today quite a bit. We also believe the third ingredient is having great tools. Great performance tools help in those first two ingredients because they help you know more about what's going on inside the APIs that you're using to accomplish what your app is trying to do. And they also can support your development lifecycle. And so we're going to show examples of that. I want to do a quick technical level set. So we're going to cover these three things. Obviously, we're going to talk a lot about Visual Studio Team System because Ed and I both work on it. So this is going to be very much a tools-oriented talk. We're going to talk in depth on .NET. When we talk about the platform, that stuff is pretty expert level. The tool stuff, we're going to get from kind of advanced into the expert level. And the process stuff is stuff even like a pointy-headed boss could appreciate. It's intermediate level, but we really think it's important. And so we want to sort of show how those three ingredients come together to form great performance in your application. Stop doing that. OK. So me and Ed, we both own performance tools, but our true passion in life is acting. We're both master thespians. And so before we jump into that, I want to do a quick motivating scenario where we hopefully something that you can relate to about the last minute before you're about to ship something and there's a performance problem appears. So at this point, I'm going to actually switch us over to the tool. And Ed here is going to be the test manager for the Dinner Now application. And I'm going to be playing the role of Steve, the developer.
OK, so we're here ready to put our latest bits into production, and I'm doing some last-minute load testing on the Dinner Now application. If you went to Cameron Skinner's talk, you saw this application, and it enables you to search for food and place an order and have it delivered to you. So I'm running this load test, and I see a problem. And the problem is, this is the load test analyzer. This view is available in Visual Studio 2008. And the upper left graph here shows page response time over time. So I'm seeing this spike at the beginning of the load test. That's not good. Let me see if I can see what page that is. And this is actually our home page. Well, that's obviously not a good way to get somebody started. So what I'm going to do here is drill into the spike. And we have a new view in Visual Studio 2010, which enables me to view the details of this spike. And what this view shows is, over time, it shows exactly what each virtual user was doing. So each row in here represents a virtual user. And what this is a great way to visualize performance problems. So right away, something jumps out at me. The first requests to the home page are taken way longer than all the other requests. So if I go back to the graphs view, Steve, we got this performance spike. It doesn't look good. Now, a good thing is I'm taking advantage of a new feature in Visual Studio 2010, which lets me take a profile of the web server while the load test was running. So I can drill into a spike, and then I can go to see what code was running when that spike hit. So what I'm going to do now is go ahead and drill into and load up the profiler with the data we collected.
So while we were actually executing the server under load, we were actually collecting data with the sampling profiler on the remote machine. This is a new feature in 2010 that allows you to run data collectors on the machine under stress so that you can figure out what they're doing. So how sampling works is that every 10 million non-halted cycles, we interrupt the application and we walk its complete stack. Now, when I say complete stack, what I mean by that is all the user mode code, both the native code and the managed code, and we get that information. So we're stopping the application at regular intervals and seeing what it's doing. This gives us a great low overhead, non-intrusive way of seeing what's going on inside the application from like sort of a statistical perspective. It's really good for telling you what's going on your CPU. So this was all happening on the machine. At the end of the run, the data got uploaded to the Team Foundation server, and when Ed pushed that button, it actually went and it pulled that file back down off the server so that we can actually investigate not only, hey, there was a problem with page load time, but what was actually going on in the code at that point. So I want to draw your attention to the performance report. These look new in Visual Studio 2010 if you've seen the 2008 product. Actually, let me stop here. How many people have actually used the Visual Studio Profiler before? Okay, good. A smattering. I'll call that, I think that's the technical term. That's a smattering of people have used it. So you can see that I have taken, it's in sampling mode, and I've collected 1,300 samples across the run. So the thing that's on the next chart below that you see is the hot path. And so this is telling me the breakdown of what the hottest paths through the application were. And we can say that for 43% of the time, it was the process request function for default ASPX. So that was that start page that we showed you, right? This one. And then also the load test that we were running would also hit the search.aspx page. And that process request time was responsible for 20% of all of the time while we were executing. And this top one is actually a service that was hosted also in ASP.NET. As you can see, these are all under the W3WP worker process. And so we have this service where we went and got restaurant categories for 15% of the time. So if I go down below that and I look on the summary page, I can see the functions that were doing the most individual work. Okay, so what does that mean? So these are the functions that we're actually executing when we actually interrupted every 10 million non-halted cycles. So the first one, I actually don't know what this is, on call. Okay, so I'm going to mark that to drill in to try to figure out what that is. The second one is a link function, toList, which takes a link query and actually executes it and builds up a collection. So I'm going to actually click on call and see if we can figure out what's going on there. So this is another new view in the Visual Studio 2010 profiler. You can see that this is a view that is all about what is going on in the function named onCall. So by default, this is showing me my samples, and I can see that 42.4% of the time was actually spent in this function. So this function was doing the work. It wasn't like it called someone to do the work. And to the left of that, I can see the functions that called that. And so I can see there was sort of a breakdown where get_restaurant categories called this a lot for the search service client. So this is the client side of a web service. And we can see that getting the menu types was the other cost. So now I've kind of figured it out. This is clearly like a dispatching method that goes and actually grabs the data from the web service. So at this point, I want to jump back to the summary page, and I want to show you another new quick feature for really getting a sense of the outline of the performance of your application really quickly. So I'm going to select this feature up here called Show Trimmed Call Tree. So what this is going to do is it's going to show me the entire call tree of the application from a performance perspective, but it's not going to show me anything unless it costs at least 2% of the overall cost. So it's really an outline. It hides all the noise, and you're seeing just the things that were expensive in your application. So let's take a look at this first root of the tree. We see, again, it's this default ASPX, which we already knew was one of the more expensive things. And we can see if I right-click here and select Expand Hot Path on Inclusive Samples, it will actually walk me down and show me the hottest path through that outline. And I can see that I'm spending, okay, so default ASPX calls the base class's process request function, kind of expected, which calls the page load of something called the search bar. So the search bar is actually this part of the application. And then that calls data binding. And data binding is where I'm spending 40% of the application. And I actually can know right away that it's binding to the restaurant category data source that was responsible for 20% of that. If I then repeat that process and move down to this other page, I can see that this data bind, again, is responsible because that search bar is on all of these pages. So this is an expensive control I have on my page. And if I drill down under that, I can see it eventually ends in that on-call method that we were looking into earlier. Okay, so that's kind of interesting. So then if I go down to the next thing, I can see 15% of the time was in the service itself. Now this is the other end of that call that we made via the data binding to get the restaurant categories. So this is the actual receiving end of that. And I can see that at the end of the day, we're spending all our time in this link query. Okay, so that's cool. So let me go and see the function details view for that query. And I'm back to this view again. I can see this is now we're looking at toList. We can see again that its body is it's spending all its time in itself. And I can see that it was called from a function called getRestaurantCategories. This keeps coming up again and again. It's this part of this control here. So I'm going to click there, and it's going to reset so that that function now becomes the one I'm investigating. Okay, great. So the other really cool thing about this view is if I pull down here, I can actually see the source code with the performance information overlaid on it. I don't know if you can see the colors from back where you're at, but the link statement is sort of a very light color, and you can see it's responsible for 1.4%. That's the cost of constructing link. But one of the interesting things about link is that it has a sort of a deferred execution model. And so you don't pay that much when you actually put the query together. It's when you actually iterate through the result of it, like for instance in a toList function, that you really pay the cost. So I can see right there, there's 13% of my application is on this one line of code. Well, the funny thing about it is if you look at this dropdown, there's like eight names in here. So, I mean, it's an obvious place where we can go, okay, I got to stop doing all this work, so let me go ahead and either hard code this. This is not going to change that frequently. And, you know, it's the last minute. I want to make a minimal change here. So I think, I mean, at this point, I can file a bug, and I can assign this to a developer, and we're good to go. So that's great. I think I've really figured out what's going on in my app. And so, you know, I saved the day. I saved our company. Hooray for me. We got a little bit lucky, but, you know, I saved the day at the last minute.
Steve, I didn't tell you. I don't know if you noticed. That was a 10-user load test.
Uh-huh.
All I have to do is run 40 users, and the server's tipping over.
Yeah.
I told you we had to do these perf tests and stress tests sooner in the process.
Yeah.
We're supposed to go into production on Monday. It's going to be a long weekend.
Okay, so maybe I didn't save the day. But that's actually sort of the moral of the story, right? Which is that sometimes, and how many people have had this situation where it's the end of you're ready to ship and you find that last minute performance problem? Is this something that people can relate to? Yeah. Okay, and there go the hands.
Okay, everybody else could go.
Yeah, you guys have already figured all this problem out. So, Visual Studio Team System gives you the set of performance tools to not only investigate these problems, but using them throughout the software development lifecycle, it makes it so that you can get a more repeatable process. And we're going to talk about that in this next half of the talk. So, everybody's familiar with the software development lifecycle. All of us develop software. So, you know, from gathering requirements through maintenance. But there's a performance task that has to be performed at each and every one of these stages. And the ironic thing is, you know, we see a lot of people doing most of their performance testing in, ironically, the testing phase. But a lot of the problems, the like really nasty ones that come up at the end that you just can't fix because, you know, you didn't get lucky, those ones get introduced really early in the design phase when you decide, hey, I'm going to go and use this API. And you didn't actually validate that it would be able to scale to the point that you want to. So at this point, I'm going to kick over to Ed, and Ed is going to walk you through the entire performance lifecycle and show you how you can use tools to support those processes.
And one thing I want to mention is maybe you're not using iterative or requirements and you're doing agile. The things we're talking about today apply equally well to agile. And I feel
I'm going to go ahead and turn this off.
Strongly there's such a thing as agile performance as well, that you're not waiting until the end, you're being agile about it, you're addressing performance as you go. But let me talk to the more iterative style and the gathering requirements phase. So you might say, well, why do we care about performance requirements? And it's really good to think about performance up front. And one thing it's going to do is help you know when you're done. And I'm going to show an example performance requirement that has some of the elements that we look for in a performance requirement. So first of all, it identifies key scenarios. And why that matters to you as a developer, you don't want to spend your time tuning parts of the application that in the end just aren't going to matter. And it seems basic, but I've seen many times where developers will spend time tuning a piece of code that in the end really just didn't matter, and they wasted their time. The second thing is it differentiates requirements and goals. A requirement is something you have to have in order to ship, and a goal is a nice to have. Well, if you have to have it, you better know when you get there. And so it's really important that requirements are measurable. And so here you can see it's a page load time requirement is specified. Another consideration is the environment or the hardware you're going to run your test on and the data that you're going to test against. I hear this a lot of times. The dev says, hey, it runs great on my box. It's really fast. Well, dude, you're running on a quad proc with 8 gig of RAM, and there's no data in your database. Of course it's going to run fast. And then consider the workload on the server at the time you're taking the performance measurements. That's another critical factor in performance. Okay, so let's look at performance during the design phase. I think everyone would agree it's a best practice to do prototype during the design and architectural phase to validate your architecture. Well, it's also a really good idea to validate the performance of your architecture. And you can do that by simply doing stopwatch testing of your prototype and making sure it's going to perform like you need it to. Now, if your team's going to deliver a particular part of the architecture, you ought to isolate that, run performance and stress tests against that to make sure it's going to perform before you make an architectural choice. And then, down the line, you're trying to get something in production and you're stuck with it. And even more importantly, let's say that you're taking a dependency on another stack or another service or a platform layer. Well, before you make and take that dependency, you better make sure it's going to perform like you need it to. And again, you don't want to be there in the last minute and stuck in a corner, unable to back out. And so my team built the load testing tools. And from the very beginning, we wanted to make a commitment to using .NET. Well, we couldn't really commit to that. We had performance goals of load we needed to be able to generate from a particular class of machine. And there's this HTTP web request class in the system.NET classes, and that's the class we wanted to use. Well, what we did very early on was write a prototype of our engine that used HTTP web request, and we saw very early on we were going to be able to achieve the performance we needed. Okay, so now let's take a look at what performance looks like during the development and test phases. To do that, I thought it'd be interesting to look at a case study of how the Team Foundation server team does performance and stress as part of their life cycle. Our load testing tools are now the de facto tools within our company, within Microsoft. Nearly every server team, every server product team, every web property, they're all using our tool set to do load testing and stress testing of their products, which is great for us. We get terrific feedback early, but teams like Microsoft SharePoint and SQL Server, Team Foundation Server, then the web properties like Hotmail and Live Earth and Ad Center, and I could go on and on. And working with all these teams, I see the processes that they take in order to do their perf and stress. And the things I'm going to show you with the TFS team, actually I see this pattern often within the company. So what I'm going to start out doing is showing you the load test that the TFS team has constructed. The TFS team does different types of tests depending on their goal. One type of test is for performance under what they would consider normal conditions. They also run short haul and long haul stress, where they're really stressing out their server to try to shake out bugs and errors that occur under high volume. And then they do pre-production runs, where before we roll hot fixes into production, we'll run a load test to make sure the hot fixes aren't going to regress performance or destabilize the server. So here's the scenarios they've set up for version control, project management, work item tracking. If you're familiar with TFS, these all look familiar. Web access. So if I drill into one of these like version control, you can see there are tests that do typical operations that people do against the version control server. And so I can drill into one of these. Let's go look at the check-in test. And this is actually using a MS test unit test. We can drive those in a load test. And the version control server is web services based, and it has a public API on the client side. And so these tests all are written to that API to drive load to the server. And then they take advantage of begin timer, end timer to take specific performance measurements within the test. So that's how actually most of these services drive load. The web access is an interesting case as well. So web access is our web client for TFS, and they use web tests to drive load. So if I open one of these, this is a coded web test, and you can see they include declarative web tests, which are the XML style of web tests. So what they do is will compose these declarative tests into different actions. And so, for example, you can see there's a run search, view work item, view homepage, etc. And here are the web actions, which are actually declarative tests. So if I open one of these up, you can see this has the URLs that are going to be executed. And you can see they're parameterized, so they can target different servers. We dynamically provision the stress and perf environments. And so the tests are all parameterized to be able to easily target different physical machines. OK, so that's how they've laid out their tests. Now I want to show you some of the things that the TFS team looks for in their reports. So as I said, that we have fundamentally three kinds of tests. There's the performance tests, the stress tests, and the pre-production tests. So if I look at one of the elements in a performance report is this trend report. And what this gives the TFS team is a really quick way to see how are they progressing toward their performance requirements over time. So there, the x-axis here is builds, and the blue line is a trend line which trends the number of scenarios that are meeting the goal. So the green bar is a count of scenarios meeting the goal, red bar, scenarios that are missing their goal, and the black bar are tests that aren't working right now. In order to run these tests are run per build. In order to maintain that, you can imagine it takes a lot of work to keep the tests up to date. So actually measuring the counter tests that are working is an important measurement to keep track of. And then for a given bar, what we can do is then drill into that. Let me back up a second. The reports I'm going to show you are custom built. We don't have these out of the box. We're working on load test reporting is a key thing we're working on. I'm going to show you some of that in Dev 10, but this is a custom report. The great thing about load tests is all the data gets pushed into a SQL server, which makes it relatively easy to build these reports. Okay, so drilling into one of those bars, then we can pull up and see for a given scenario why it's failing. And these are sorted by actually delta to goal. So you can see there's a delta to goal and a delta to build column. So right here we can see this particular scenario regressed 111% from the last run. And so we'll go ahead and file a bug on that. And now the developer, they're doing a check and they have no idea they regress performance. And by running these tests regularly, we're able to catch that early and then go back and look at the set of change sets that have been checked in during that time period. And and we're going to show you some neat tooling with the profiler that you can use to difference two builds. Okay, now this is a stress report. We run two types of stress tests. One's a long-haul stress. So we're going to run that for a week and look for things like memory leaks and server stability. And then short-haul stress, and that's what this is a report of, is a short-haul stress. And short-haul, what we do is we pick a build at the beginning of the week, and then we run stress on it over and over that week. And the reason is the bugs we find during stress testing are very slippery bugs. They don't repro. Dev's not going to be able to repro them on their box. And even run to run, we might not see the same bug. So what we're going to do is pick a build. And so here's a particular build. And the blue bars are count of runs that were executed against that build. And the red bar is a count of errors. And then if I look at this, you can see we didn't complete many runs, but found quite a few errors. And what happens if we're seeing an error over and over, then we'll design an experiment and tweak our load test to isolate that one service to try to really reproduce the error, and then hook a debugger up to the server to try to, depends on the type of problem it is, it would determine the technique we use, but then hook up a debugger so we're able to catch the error. And then finally, if you notice when I showed you the load test, there was a lot of percentages in the test mix for version control. And for our pre-production runs, one of the things we do is the Team Foundation server logs every web service call into a database table. And so what we do is we take in transaction counts out of our production server, and then we compare that to transaction counts that we're getting out of our load tests and compare the weighting. And this has given us some assurance that our tests are actually doing what people are doing on our production server. So that's a look at what the TFS team is doing. And I want to push this back and kind of summarize some of the best practices we saw for you to consider. And the first one is start early. When we started on the Team Foundation server, we were building the load testing tool right at that same time. And we were barely into it, and we were running stress tests already. So my very first dog fooder was the TFS team. And we were able to shake out bugs early. And you can see we do focus on key scenarios. Again, you want to make sure you're investing in the right places. Run tests regularly. It's a lot of work to run these tests. Daily may not be the right thing, but consider weekly or monthly. But doing regular performance testing is important. You can see we're measuring against requirements. Again, it's good to know when you're done and how good is good enough. Perf is the kind of thing you can spend a lot of time tuning, and you're trading that off against other things. So you want to be smart about how you're spending your time tuning. The other thing is, I talked about that during the stress testing, but we're able to isolate components in TFS. So I have talked to a customer who works in an environment where they have a central load testing service. And this customer is delivering a key component to a larger integration project, and they were running performance tests as part of their development process. And so they're able to measure that, yeah, we're getting good performance, the performance we need. And then they push their bits into this production environment, and the guys in central QA saying, hey, we're load testing this stuff, it's hitting the wall, you have a performance problem. And they're able to come back and say, well, no, we don't. And here's the numbers. It's got to be an environmental problem. And so instead of having somebody breathe in over your neck in a production environment, and you're sweating trying to figure out what's going on, by doing this as part of the process, it's going to be much better off for you and avoid late surprises. And then, I talked to this, spending tuning time wisely, and doing pre-production testing. And I think it's really important that you find a way to test on the hardware that you're going to deploy to. Part of scale is you may think we're going to get linear scale. And I can tell you from Team Foundation server, we were running on a 4-way. We ran out of CPU cycles. We were pegging the CPU. So we went in and got an 8-way and plugged in the 8-way. And the 8-way just barely got over half CPU utilization. Well, we should have gotten twice the throughput. What's going on? Well, at that point, it became not CPU bound, but it became IO bound. And performance is that way. You tackle one problem, and you get a little bit further, and then you're going to hit the next problem, the next resource limitation. And so by actually testing on the hardware that you're planning to deploy on, you can also avoid the surprises. OK, so I showed you how the TFS team is using unit tests and web tests as performance tests. In Dev 10, we're introducing a new test type, which is UI tests, which drive from the UI layer. And so I'm going to show you how you can use those as a performance test. And then we're going to show a new feature in the profiler, which is actually JavaScript profiling. OK, so I have a test application that's calling JavaScript. And it's a very simple application. And so what I'm going to do is create a new test type to test the homepage for that app. So to do that, I add a new test. And there's this new test type, coded UI test. And so I go ahead and create that. And now I get prompted on there's different ways to create these tests. I'm going to go ahead and launch the recorder. And so what this is going to do is record my actions as I do them on the application. So I'm going to go ahead and record and launch IE. And bring up this page. It's the My Finance page. And then get the data. So very simple. I'm going to do that, and I'm done. So here I'm going to generate code. And close out the recorder. OK, so what this does is generate looks very much like a unit test. You can see it's a test method with a coded UI test. And the recorded code gets factored into its own function. And the good practice here is to factor your code into discrete steps so that, for maintainability, if you're going to have to fix one part of it, you can just have to fix that part. OK, so I'm going to go ahead and run this test to make sure it's working. And so this is going to bring up IE and go to that home page. Now, here it is driving the UI. One thing about this, what I'm going to show you in a minute is actually using this in a load test. OK, so there it completed successfully. So we can have a look at that. And so now I'm going to add this to a load test. And in this case, it's not really going to be a load test. So a better name for this kind of test would actually be a performance test. And I'm going to show you how you can do this. So I'm going to go ahead and create a load test. This is our load test wizard. And for this testing, I'm going to use a single user load. There's exactly one mouse and one keyboard on this computer. So if I try to run more than one UI test at the same time, they're going to be fighting for the mouse and keyboard. That just doesn't work very well. But I can run a single user here. And if I wanted to, as part of this test, I could also define a new scenario that would be using web test and unit test to actually drive load to the server to put it under some duress. But for this demo, I'm just going to do a single user. And go ahead and add that test that I just created. It's actually this one. And then in my run settings, instead of running for a duration, I'm going to say to run 3 times so I can shake out some standard deviation in the performance. Okay, and I'm going to go ahead and run this test. And so what this is going to do is run through the test 3 times. Something I forgot to do. Part of load test, it makes it really easy to collect performance counters off the machine under test during the load test. And when I was running the wizard, I forgot to do that. I can show you how to do that in a minute. It's going to run through these 3 iterations, and all the while it's taking the measurement of the time it takes to run the test. So this is using the advantage of using the load test here is to collect the performance counters, and to it's going to roll up averages and give me good performance statistics off the run. Also, one thing we've done in the bits, this is where I'm showing you CTP bits, and since then we've added a few features. One of them is a sequential mix, which will run through tests one at a time. And so what you can do is add multiple UI tests to the load test at the same time and use that to do single user performance runs. Okay, so I've finished my test. You can see we've got a nice report that shows it took an average of 12.1 seconds to run the test. Okay, so now what we're going to do is show the JavaScript profiling feature. And Steve is going to show that.
Thanks, Ed. So any kind of test running inside Visual Studio can be profiled. And so now that we've got a performance test, again, the next thing we're definitely going to want to do is find out what is the performance, like what is actually going on in the code. So I've opened up the profiling run for that same test that we were executing. And we can see that if we jump to the call tree view, I'm going to hit that button to get that performance outline that we talked about earlier. And you can see right away, not only do I see what's going on in Internet Explorer in the JavaScript, I'm also seeing what's going on in the server. So you can see I spent about 896 milliseconds actually performing the get daily data complete function in the JavaScript. And I can also see that I spent 400 milliseconds actually calling the web request from inside my JavaScript. And then I can also see that I spent 315 milliseconds actually building the page itself. So it's sort of being able to get an end-to-end view of what's going on in the code while that test was running to help you identify the performance problems.
Is that cool? That's pretty cool. We got JavaScript profiling, UI tests. You can use as performance tests and measure at the UI layer. So it's pretty powerful stuff. Okay, I just want to summarize here. We saw some different ways to take performance measurements, and this gives you a way to think about that. So first, think about what it is you're trying to test, what the target layer is, and what your load is going to be while you're taking the performance measurements, and then how big the data is. And so, for example, you can start out, the best place to start, single user performance tests against a small database, and then go to an expected size database. And it's amazing how many problems we see just with this. Most problems, the initial problems are related to data. And so by scaling up your data, you're going to find a significant number of problems. And then you can look at doing load tests. Again, start slow, ramp up. I work with a lot of consultants who work with customers, and they'll go in and say, well, how many users do you think your application will scale to? Oh, 1,200, 1,500, and it tanks at 20 users. So you got to start slow and build up, and then look at doing some stress tests with lots of load, lots of data. Okay, so some deployment and maintenance considerations. We saw how TFS does stress and load tests as part of their deployment cycle. I'm going to show you how you can use a new feature in Dev 10 to quickly spot regressions. So I'm going back to the load test we were looking at earlier, and I'm going to show you a new feature we have, which is Excel reporting for performance results. So what this feature does is, I mentioned before, the performance data is stored in a SQL database. And so this will enable you to quickly build performance reports in Excel. So I'm going to choose to use a template and use a report that I built previously. And select which runs I want to include as part of this report. And then next, I can choose which performance counters to use as part of the report. And this will give me an option to pick any of the counters we collected as part of the test. So I'm going to use response time and the basic memory network disk and processor off the machine under test. And hit finish. And this will go ahead and create the report. So what this is doing is creating Excel workbooks for each of the counters that I selected, and it's going to show me over time what the performance was doing. Okay, so for example, if I look at the average page time, you can see this is charting page time, run over run, and here I can see a regression on one of the pages. And so this will give you that trend report that's so important to understand the health of your product. So you like that? Yeah. Okay, and now the other feature is that you can do profiler differencing. And this feature is actually in Visual Studio 2008, and Steve's going to use that, how you can also use that to isolate a regression.
Right. So all the performance functionality, for those of you guys who haven't actually used it before, is actually hidden here in the Analyze menu. So if I select the second option here, Compare Performance Reports, as you remember from the opening demo, as we're running those load tests, we're putting all of this data into TFS about what was going on inside your app. So I've actually pulled those files down already, and I'm going to choose my baseline from when it was a build that was still working kind of good, and I'm going to choose the regression from the build that was not going as well. And so what I'm going to do is I'm going to click OK. It's going to load both of those reports up, and it's going to do a comparison of the two reports for me. So I'm going to select exclusive samples. This is the this will tell me which function was executing most frequently and the ones that changed the most between the two builds. I'm going to apply. Oh, okay, wait, that's a lot of data. So I'm actually going to increase the threshold to get a little of the noise out of there. And so now you can see, in a really quick way, by just taking this data that we've already collected and throwing it at this, we can see our two bad functions. And from here, we can get straight to toList. We can jump straight to the matching role in the regression file, and I can get straight to that source code that we had seen earlier. So, I mean, it's just so much easier when you've gone through the trouble of collecting the data, because it can show you that function that's changed, and you don't have to do the full analysis of figuring out, oh, well, that was already one we knew about, et cetera, et cetera. So that's run-to-run comparison, and I'm pushing this the wrong way, and I'm pushing it the right way. So at this point, that sort of brings the performance lifecycle part of the talk to an end. One of the coolest parts of my job is that I get to work with a lot of customers and Microsoft consulting people and other product teams to see how they are using the tools on their own applications. So that means I get a lot of feedback on the things that go wrong a lot in their applications. And so I've taken some of that information, and I'm going to use it to sort of show you a couple of common performance problems that we've seen and how you would detect them in the tool. So first up, here's a very simple, innocuous-looking struct. There's a feature inside Visual Studio Team System called code analysis. Have you guys used it? Perhaps you went to Rob's talk right before this? Anyone? Yeah, OK. So wouldn't it be great if, we say, get these things out early? Well, how much earlier can you get them than not being allowed to check them in the first place? So this is a really innocuous-looking struct, but there's something that's potentially hiding behind the surface here. And if you were to run fxcop on it, what it would show you is that, hey, you've got this struct, and it's public, and it's sitting in the public API for your application. And you haven't actually overridden the equals or the unequals thing. Well, what do people do with structs? They put them in collections and otherwise compare them to things, right? But if you don't actually override this, then the .NET runtime has to resort to reflection to go and actually compare things. And reflection, if you can get away with not doing reflection, that would solve many of our customers' problems. So again, a really easy, quick way of finding something that might not be a problem right now, but will be a problem when someone uses this API in a different way. Okay, so that's the first thing I want to talk about. Next up, I want to give a really simple ASP.NET application. Indeed, there are a few that are simpler. So all we've got here is a SQL data source that grabs a bunch of rows from a table. And then we bind them to a drop-down list. So I'll tell you that I'm going to show you this application in a minute, and I'm going to show you that it's going to look fine. You can put 1, 2 users on it. It's no problem. But as soon as you get this guy under load, it's going to fall down. And so keep in the back of your mind, see if I'm going to go through some theory and see if you can think up what is actually the problem here. So I want to talk a little bit about generational garbage collection. So there's this generational theorem that the behavior of the garbage collector is based on. And that theory goes like this. Objects that were just allocated are probably about to die. This sort of makes a certain amount of intuitive sense if you think about your applications and how you use them. You know, you write new up something, you set a couple properties, you call a function on it, and then you're done with it. You're done with it. And that's actually a very common allocation pattern. The second one is that if you've created something and you've been using it and using it and using it, it's probably going to keep on using it. And so the garbage collector is tuned to assume that you're going to follow one of these two patterns. And let me talk a little bit about how that actually works under the covers, using the correct thing. So this is sort of a diagram of what the .NET heap looks like. We've got two major heap portions. One of them is the large object heap. Anything greater than 85 kilobytes will end up in the large object heap. The large object heap is non-compacting. Large objects are expensive to move around, and so you put something in the large object heap, make sure you need it there. The small object heap is divided up into generations. So all of the objects that are intended to be short-lived are in generation 0, and the long-lived objects tend to move into Gen 2 as garbage collection goes through. Let me walk you through that process. So if I have a new object that gets allocated, all objects are allocated into Gen 0. But as you can see, that object I just put in there kind of filled it up. So when the next object comes around, Gen 0 is full. And so we're going to have to start garbage collection. So the first thing that happens is we identify which are the dead objects. And we those ones we don't need anymore, so that space we're going to get back. The ones that are not dead are going to get promoted to the next generation. And so Gen 0, it's not that large. You can have a decent number of Gen 0 collections happening in your application, and it's not that costly. Gen 1, it's a little, whenever you clean Gen 1, you also have to clean Gen 0. So now, it's a little bit more costly to get Gen 1 than Gen 0. When you have to clean Gen 2, you have to clean Gen 2, which is very large, frequently, Gen 1, and Gen 0. And so that's when you start getting into trouble. So moral of the story is you want like a 10-10-10 kind of ratio, ideally, between Gen 0, Gen 1, and Gen 2, by which I mean Gen 1 collections are about 10 times less frequent than the ones in Gen 0, and the Gen 2 collections are about 10 times less frequent than the ones in Gen 1. So now that we know that, there's 3 bad allocation patterns I want to talk about. And a bad allocation pattern is anything that sort of doesn't match the theorem that we sort of talked about earlier. So the first one is called midlife crisis. It's kind of a catchy name. It's any object that lives just long enough to get into Gen 2, gets promoted twice, and then it dies. Well, okay, we already said Gen 2 collections are expensive, so that's why you don't really want to have one of these. There's actually a rule that will fire inside the profiler if we detect that you have more than, I believe it's 5% of your objects in midlife crisis, because it is that dangerous. The second one is managed leaks. Managed leaks are not the same thing as native leaks. This isn't, obviously it's not, I forgot to delete. It usually means that I'm holding on to a reference somewhere so that in the step where we go and locate the dead objects, your object is never dead. I see this a lot in caches, right? Hey, I need to get this again really soon, so I'm going to hold on to it. And then you never let it go. And you get down that chain far enough, and you've got things that are hanging around forever. So I'll show you how to look up all these patterns in a second. The third thing is that large object heap we talked about. If you're getting a lot of things into the large object heap and you don't intend to, well, you're going to get a little bit of fragmentation. It's going to be a problem. So I'm going to show you how to find each and every one of these inside the profiler. So at this point, I'm going to switch back over, and I'm going to show you that application that we talked about a few seconds ago. I'm actually going to reuse this one. So I'm going to load up that web application. And let me just show it to you right as soon as this finishes. We actually brought a big giant box with us from Redmond to make these Hyper-Vs run faster, but not fast enough. Sorry about this. Great. OK, here's my app. There's Ed's thing going away. Sorry about this, folks. And we're good. So the application starts up, and it's exactly the thing that we talked about earlier. It is a very simple drop-down list with a, I think there's a couple hundred items in here. So what I'm going to do is I'm going to run this thing under one of the more advanced modes of the profiler. I'm going to select the performance wizard to get started. I'm going to put this in instrumentation mode because I want to check the beginnings and ends of every function and where every object falls inside of that. It's automatically detected that I have web application 1 in the project. I'm going to select that. I'm actually going to uncheck this because we're all experts here. I'm going to go ahead and do some advanced tweaking on the performance session. So I don't want it to launch immediately. So that brings up the Performance Explorer, and it creates a performance session that has all of the settings for the experiment that we're about to run. I'm going to tweak this just a little. So here you see .NET Memory Profiling Collection. I'm going to collect .NET Object Allocation information, and I'm also going to collect .NET Object Lifetime information. So what's going to happen while this application is running is I'm going to get information about every time we allocate an object and every time we deallocate an object so that we know what generation that guy went out in.
You didn't check.
So I should check that, and I'd like to thank the audience for reminding me of that, because that would have been silly. All right. Now I'm going to push the green launching button, and it's going to actually get deallocation in addition to allocation information. So the application is going to come up here. I'm going to simulate extremely light load on it using a old-fashioned technique without the automated test runs. We do this by 1, all right, 2, okay, 3, 4. There's a reason why it's 5. Trust me. 5. Okay. So now we've got our information about the allocations and deallocations. So now it's going to analyze all that data super fast. And I'm going to bring up a new report. This is a memory report. So the first thing I see I allocated about 10 megabytes worth of objects in that small amount of time. And I also see that I don't have the names of my functions for reasons that I'm going to really quick. Never seen that one before. Actually, sorry about that. You do it 100 times and it works, and then you're on stage and you don't sacrifice to the demo chicken. And not so much. 1, 2, 3, 4, 5. Go away. Ah, jeez. Okay. Object lifetime view. let's go ahead and pretend this says string. This says system string here. And what it's telling me is that there were about 39,000 of these things allocated. These columns right here are Gen 2 instances that were collected and Gen 2 bytes that were collected. What does this remind us of back before the demo disaster? Yes, that reminds us of midlife crisis. So we see that there were no objects that were actually cleaned up once they got into Gen 2. So we've ruled out midlife crisis as a possibility. This next column is instances that were alive at the end. So we see that there are actually several of those, and that's okay. Because they were actually a small amount, and I was kind of expecting them to get there. So those aren't really leaks. But if I scroll over here, I can see that I had 5 objects get into the large object heap. And you know, because I did it several times, that I clicked that button 5 times. And so now I've got a pretty interesting thing going on here. I know that that I have strings, 5 strings, 1 per request, that are getting into the large object heap. So that means I've got some object that's 85K getting in there every single time somebody goes onto this thing. Okay, clearly not going to scale. So, yeah, that's not going to work. Okay, so I started thinking about this, and this is actually one of the things, whenever I tell it to another performance guy who's out there in the fields working with people, they laugh because they see this so often. Where is these strings being allocated? And so actually, if we go to this app and we look into the source of the page, I think I may have found a large string. So what this is it's the view state. See, designers are wonderful things. You go in, you saw the little designer view where I go and I got my pretty, I had the app laid out like that. But the thing is, the designers are about making your life easier as a programmer. They're not necessarily about getting the greatest performance. And so most ASP.NET web controls, they have the view set enabled by default. And we're not actually using it for anything here. We don't need it there. So if I simply set that off in the designer, suddenly none of these objects get into the view state. And this happens all the time. We see this very commonly. So that was .NET memory problems. I want to talk a little bit about a new class of performance problems that we're seeing more and more as time moves on. The reason it's becoming more and more important is because as we get these multi-core machines, I mean, who's got like a dual core on their machine, on their desk? Okay, lots of you. Quad cores? Wow. So that was like about 25% of the audience actually already has a quad core on their desk. People want to use these things. They want to get more out of performance as they use them. And so we're moving to more and more multi-threaded programming. And we really want to get a sense of, hey, where are the places where I'm starting to get contended? Where are the places where I have a lock that is preventing me from getting further benefit out of having all of these cores on my chip? And so in 2010, we've added a new mode called contention profiling that is very low overhead and non-intrusive, in the sense that how it works is that every time you take a lock and the lock acquisition actually fails, so every time you block while taking a lock, we will walk the stack and time the amount of time that you were blocked. So let me show you how that works. So I'm going to switch to don't want that. Another application, and this is a very simple producer-consumer app. And what it does is you've got maybe 4 or 5 threads fighting over each other. One of them is producing items onto a queue. The other 3 or 4 are actually dequeuing items off the work queue. It's a very simple application, but it's illustrative of what I'm trying to get at here. So that's what the application does. So I know I've got this contention. Can I find it with the tool? So I'm going to the Analyze menu. I'm going to launch the Performance Wizard again. And actually, I'm going to rebuild the solution, because I think that was the problem from the last one. And I'm going to launch the Performance Wizard. And I'm going to select this thread contention view, which is the mode that I was just talking about. Again, it will pick up the application I'd like to target for performing. And I'm going to actually let it go ahead and launch the application. So while it's executing, it's going ahead and it's walking the stack every time it tries to grab a lock and it fails. So I'll let it do its thing here. So the information that we're collecting is, again, the entire stack of the application. And we're done. Oh, seriously? Yeah, maybe I should restart Visual Studio. Thank you.
Use the other instance.
100 times this worked. 100 times. Yeah, I forgot about the 101 bug, right? It fit in the... So that's a good question. While we're doing that, let's talk to the question. The question is, what of this is in 2008? So the differencing of the profiler reports, that was all in 2008. The sampling mode is in 2008, but the collecting data remotely while you're executing a load test is not. The wizard has been improved, so we haven't added, but all the memory stuff that I showed is actually in 2008. You just have to go and twiddle the bits like I showed you. And success, yay. Okay, so we saw that there were 7 total contentions. We saw that basically the functions that were blocking the most were called it was actually the monitor enter, the managed monitor entry. But the thing I want to actually point out here is that we know that there was a single handle that had 100% of the blocking was over a single handle. So I'm going to actually go to that handle. And I'm going to expand all under that. And I can quickly see that there was a DQ, there were 5 contentions of those, and they were responsible for 3.2 seconds worth of waiting. I can also see that there was a single contention for the producer enqueuing onto the queue, and that one was a very short one. Likewise, we see there was a single contention under done. So what's really cool about this is that if I go to the function details view that I've showed you a couple times, this big blue thing, and I scroll down the source code to the function, I can actually show you the exact line in your code where that lock was taken. And so that's a really great way to find your problem. Thank you. Great. OK, so we're getting towards the end here, folks. So I want to talk about what's cool and new in Visual Studio Team System 10.
Well, we showed many of these features already. I just want to point a couple out. We have extensible data collectors, which we're using for the profiler during load testing. But we can add additional. Others can add data collectors to collect interesting data during a load test. I showed you the log visualization. That's a very cool feature. And we have new design time extensibility points for you to extend the design time experience for web tests and load tests.
OK, so gosh darn it. So the big one I want to highlight here is that the profiler now works under virtualization. Oh, yay. Yay. OK, so the takeaway from that, and indeed, it's running under virtualization right now. That's what we're showing. So I'm going to blame that for the bug. No. No, so what that means is that you can actually use it in the CTP that you've got sitting on your hard drive. The other thing I want to talk about, rules and guidance. These are common problems that we've seen. We actually have authored rules that will fire automatically to warn you about things. The canonical example is, hey, you're concatenating a lot of strings. Wouldn't it be great if you used String Builder instead? So we're trying to find more and more ways for us to help you find these problems automatically. The other one that's really cool is just my code profiling. This allows you to get, it takes out a lot of the framework code that, hey, let's face it, you can't change anyways. So that we're focused mostly on the code that's just yours. It really makes it easier to see your performance problems. So I really want to encourage everyone to take the CTP. It's on your hard drive. Put it through its paces. Give us feedback. Try to write a performance test. Try to profile it. Let us know what you think. That'd be great. Me and Ed are always hanging out on the forums. We read every post. Get to know your tools. There's blogs for the profiler. There's blogs for the web and load test stuff. Also, I want to call out what we call the Big Blue Book. This is, you've got to know your platform. It's a book called Improving .NET Performance and Scalability. It's up on MSDN. We've used it, Ed used it to define all the thresholds that he's looking for in load test. We use it to define what the rules and guidance should be. It's just a treasure trove. It's like 500 pages. You can't go to any of these talks because they're all over. But fortunately for you, everything has been recorded. So go ahead and jump on the PDC site and download some of these. Ones I want to call out in particular, the gentleman in the front asked about some of those other modes that were on the wizard. That first talk, bringing out the best in multi-core systems, is actually about the one at the bottom entitled Concurrency Analysis. It's all about concurrency profiling. It's really cool. Also, there's some stuff on JavaScript applications and other team system talks. Fill out your evals. You can say, demo didn't work. OK. And please, if you've got Q&A, thank you very much. The microphones, if you could use those so that the people who are, again, watching us while we are trapped inside of their iPod and Zune can hear you. And, or we could just wait a second while the...
It's not on?
Yep.
Okay. Now it's working.
Is this one on?
Yeah.
Yes.
We can hear you.
Okay,
I
great.
can't see you, but we can
I'm
hear
here.
you.
Right in the middle.
Okay. I have a question. Could you explain which features are in Visual Studio Team System for developers and testers? Just to get clear what edition I need or if I need this
You're
suite.
all test, I'm all dev.
Yeah, so the load testing features and coded UI are in Team Test. The profilers in Team Dev.
Okay.
So they're all in Team Suite.
Okay, great. Thank you.
Are any of these in professional? 2008 professional?
No. None of them are in professional, unfortunately, at this point. We get that feedback a lot, though. Yeah, we
Hello.
Go for it.
So you have been talking about memory leaks.
Yeah.
Do you have some special tools helping us to pinpoint the memory leaks and to visualize the dependencies?
So you like in terms of walking the references and stuff like that?
Something like that, yes.
Yeah, not in this release. It's a problem that we're really interested in, but we haven't actually built anything like that yet.
But the memory profiler we showed will show you at the end of the run how many objects are still in the heap, and that, you know, of each type, and that gives you a really good clue where to go look.
Okay, thank you.
Yep.
Yeah, quick question with some of the profiling tools. I know the memory profile is probably out, but is there any support with any of this for either native or blended code?
Yeah, so with the exception of memory, which you've called out, everything works for native. Sampling works for native. Instrumentation works for native. The contention stuff works for native.
Of course, you can drive load to any server. And using unit test, if it has an API you can call from .NET, you can drive load to it.
Yeah, we love native code too. Absolutely.
Okay, cool, thanks.
So with the view state example, you showed that there was 5 objects in a large object heap.
Yeah.
And then you jumped right over to view source because you knew the answer to the question.
Well, I jumped right over because I didn't have the symbols to show you how to do the next step, which was that you can actually jump from there to the type view. The type view will tell you the function that's allocating it, and the function that's allocating it was the page itself. So that tells you the strings on the page.
So,
Right?
something I want to point out there, really good thing to do would be to write a web test that drives that page, and then do a validation rule that validates response size. And you could say, well, if response size is larger than 100K, fail the test. So that's a good way to find those problems too. And they jump out in the web test result view. Those large responses really jump out.
All right, thanks.
Yeah.
Real quick, what about dynamic profiling for like all the C#4 futures right over here?
Okay. So the problem is usually symbols. We don't get really great symbols when you have generated dynamic code, truth be told.
Okay.
So you'll see like the calls that you make into like the frameworks from it, but we don't get good symbols on things like the dynamically generated things. It's something we're still sort of trying to figure out what the right thing to do is.
Gotcha. And one other quick thing. When you're comparing load tests, can you bring up the source files and do almost like line by line comparison, saying this ran faster previous versus this?
That's a really good idea. No, actually, we have today. It's like from that. Remember that view I showed where it was like deltas, and then you could switch to either the comparison. So you could get the two files up side by side and then go to the same function, and that would simulate that.
Okay. All right. Thanks.
Regarding UI testing, does the UI automation library, is that improved in regards to WinForms? So you can automatically test WinForms applications as well?
Yes.
Okay, so you don't have to use stuff like the white projects like you have to do today to go around it?
Correct.
Okay,
yeah,
thanks.
This will target WinForms projects.
What was the question?
Yeah, that's answered.
WPF?
Oh, the question was, does UI test support WPF? And by the time we RTM, they will.
But not in the bits on your thing.
Go ahead.
Yeah.
I apologize ahead of time if this is a silly question, but is it possible to profile a live server?
Yeah. So there's nothing to stop you. And indeed, there's a feature that, again, is not in your CTPs, but that are for attaching to a live server. Right now, in 2008, usually you have to, for managed code, you've got to reboot it to get these environment variables.
Bounce the process.
You got to bounce the, good point, bounce the server process, which usually kills repros. But we're working on that for Dev 10, for the VS 2010 product, so that you'll be able to actually walk up and attach.
So if you have a server in a server farm, you could take it out of the load balance, do what you have to do, put it back in.
We do some things to try to make this easy for you. There's actually on the disk, we put something called vsprofiler.exe. This is like a really tiny 8K thing that when you install it, it just puts down these command line stuff so that you can just do command line stuff, so you don't have to like install Visual Studio on your server, which you really don't want to do.
Thank you.
Very good. And a question regarding locking. If I do a test on an environment with, let's say, 2 or 4 processors, I can be pretty sure that maybe some other locking issue can happen when I go in production environment with 8, 16 or more cores. Because it's a problem to find the resources to make this kind of test.
I mean, there are certain static analysis tools that like I think, but realistically for locking, I think you really want to actually at least try it on the size. You can't guarantee that those things will scale out, right?
Yeah, but certainly you're going to, if you do tests on a 4-way, you're going to find a bunch of problems. Shake those out before you go to the 8-way.
Yeah, and then put it on the 8-way.
Yeah.
And then the 16-way.
You might find some new problems when you scale up.
Hardware's free, right? Okay, anything else? Oh, here's another. Yes?
I have a question. In the load test results, wouldn't it be a good feature to see what you're measuring? For example, like a tooltip, what do you mean with max as a column header or the unit? That's in milliseconds, something like this?
Oh yeah, you mean to display the units, if it's seconds or milliseconds. Yeah, that's a great idea. Okay. Yeah.
One over here?
Yeah, keep going, guys. We're
sort of on the UI tests. So you showed an example of where you had one up and it was running on the one machine. There are some other tools on the market right now that will allow you to synchronize multiple computers so that you can do sort of simultaneous action UI-based testing.
Yep.
Would we be able to potentially use the controllers and agents to synchronize computers and sort of do that? Everybody presses that unique button at the same time, because that's a little challenging to do in the web test model at the moment because of the way that web tests stagger. So is there any thoughts around that?
Yeah, so a couple thoughts there. One is you can run agents on the key thing is the UI tests need access to the mouse and keyboard, which they have to be running on a desktop. And so you can set up your agents to actually run on the desktop instead of as a service. And so once you do that, then you'll be able to send UI tests over there. And then within a scenario, there's not a way to synchronize as the test goes. You can get them all started at the same time. But after a while, there's going to be drift. And right now, we don't have a way to, the tools call them synchronization points, to say, wait, all the users wait until they get to this particular point, and then go. We do have a sample that would do that within a single agent, up on Bill Barnett's blog. And if you go to my blog, there's a pointer to links to info. It's linked there.
Okay.
I think for Coded UI, I'd have to think about that. I don't know that there'd be a good way to do that.
Yeah,
without writing your own communications code.
Well, for some of the stuff that you were showing today, that's I find in my experience in test that it's those very light number of user tests that are in synchronous that tend to pop a lot of these problems up, because that's where the contention's coming from, right?
Yeah.
Sometimes you don't need 1,000 users to prove that you've
got
right. Some kind of thread contention or something like that.
Yes, yes.
That's really good feedback. Thank you. Okay.
One more.
Oh, sorry, I cannot see you guys at all.
SharePoint web parts. Do these tools support profiling them?
I can't think of a reason why it wouldn't. I mean, as long as you attach to the right process, it's managed process, it should be good. Okay. Is there anyone else who I can't see actually standing in front of a microphone right now?
No.
Yeah, there is. No? No, he's sitting down.
All right.
We're good.
Thanks for coming.